everyone to be aware that we use ratios to do that question. Okay, we use ratios to do that question. But I'm just zooming it was a little bit faint so that those who are at the back can see. All right, so this is our diagram. Right, we are given our ratios there. Okay. These two lines are parallel. That is, AQ is parallel to RT. Okay, and you are given two ratios. Right? So, based on BQ over QC, that is BQ over QC, it means that the length of BQ, okay, since we are told here, since we are told that BT is equal to K, okay, we need to calculate TQ. I would suggest that you make BQ equal to 3Q, okay, so that you won't end up having two constants, right? We are told that BT is equal to K. Since BT is along BC, and we know the ratio of BQ over QC, it would make sense to say BQ is equal to what? 3K, and QC is equal to 5K. So that it makes things easier for you later on. All right? So that's what I'm going to do. So this BQ is going to be 3K. The QC is going to be 5K. Okay? Then we have another ratio, which is BR over RA is equal to a half. Okay? So I need to introduce a second constant. My BR is this one here. I can introduce maybe Y or X here. So let me call it Y. So that will be Y. My BR will be Y. My AR will be 2Y. Okay? Now once you do this, it will make things easier as you move forward. Okay? Then, so our BT is equal to K. So this is going to be K from here to there. And we want the length of TQ in terms of K. So we have to identify a triangle that we can use the proportion theorem in it, and then we can get the length of TQ in terms of K. So the triangle that I'm going to identify is, I'm going to identify triangle BQA or ABQ. Okay, let's call it ABQ. Okay, because I know that the ratios of BR and RA are given. Since we have a line which is parallel here to AQ, it means I'm going to identify triangle ABQ and then use the proportion theorem to get the length of TQ. Okay, so do you mind if I go to the next page? Let me go to the next page. So my next question would be to say, in triangle, let me write the question. It's 8.1. So this is 8.1. So in triangle ABQ, okay, we want to get BT. So I'm going to say BT over TQ is going to be equal to BR over RA. So it will be BT over TQ is going to be equal to BR over RA. And then my reason for that is line parallel to one side of triangle. Okay, now my BT, we are told that it's K, and we want TQ. My BR in terms of y, it's equal to y in my AR is equal to 2y. So that will be y over 2y. And these two cancel. So your k is going to be equal to, okay, remember 1 TQ, sorry, that will be, so that will be TQ is going to be equal to 2k. Okay? Because these two will cancel out. So you end up having k over TQ is equal to 1 over 2. Then you cross multiply. And you get TQ equal to 2k. Okay? How many of you got that? Right? So this shouldn't be a problem. Right? Also, if you consider BQ as 3k, you can see that TQ is going to be 3k minus k. But I suggest to you that since it's 3 marks, you need to show you're working like this to get the full 3 marks. Because the use of the proportion theorem is very, very important for the question. Okay, so that's the first part. Right? Then, the next question says, hence, or otherwise calculate the numerical value of CP over PR. Now, your CP is from here to there, okay? And your PR obviously is from here to there, okay? Now, for you to be able to get that ratio, again, you need to identify another triangle that you can use the proportion theorem. So, the triangle is going to be, I'll call it CTQ, okay? Because RT is parallel to PQ. Okay, so my second triangle is going to be triangle CTQ. So that would be in triangle CTQ. I'm going to have CQ over TQ is equal to CP over PR. Or rather, I can just write it based on what I have here. So I'll start with saying PC or CP over PR. Okay? So I'll say CP over PR is equal to CQ over QT. CQ. Yes?
How is CTQ a triangle?
Oh, sorry. CTR. Sorry. CTR. Okay, so that's what you have there. We write our this line parallel to one side of triangle. Okay, now CP over PR will be equal to. Now, if you go back to the diagram, right, this CQ is 5K. TQ, we got it as 2K. So it's very easy to be 5K over what? Over 2K. So this becomes 5K over 2K, and those two cancel. So the ratio of CP over PR will be equal to 5 over 2. And then you're done. Right? So it's very straightforward. Okay. Then the one which you had challenges with. I expect everyone to have done this question, then you are supposed to be marking your work. Okay? Not writing from scratch now. Right. Now, for you to be able to find the ratio of triangle RCT, okay, it's RCT. Okay, let me use a different color. Triangle RCT is this one. Okay? Then triangle ABC is the bigger one. Okay, let me use different color like that. So this is our triangle ABC. Okay? Okay, the pen is good. There's something wrong with the pen now. Alright. Do we have a common vertex? We have a common vertex. We've got that. Okay? But are the bases on the same line? Okay, because if that's the common vertex, means for triangle ABC, we can easily draw the height for triangle ABC. But the height of ABC won't be equal to the height of triangle CRT, because the base of CRT won't be along the line AB. Now, because of that, we can't say that the ratio of the areas is equal to the ratio of their bases. You can only say the ratio of areas of two triangles that share a common vertex is equal to the ratio of their bases, because they will be sharing the same height if the bases are on the same line. But they are not. Okay? Also, do we have a common angle? No. So we can't use half base times height. Okay? We cannot use the area rule. We can't use half base times height because we don't know the heights of both triangles. Okay? Also, they don't have the same height. So for this question here, all the concepts that we have used so far to determine the ratio of areas of two triangles don't work. Okay? So the only way is to identify a triangle, a common triangle for both of them, such that we can use any one of the concepts we've used in the past. Okay? We need to identify a third triangle, a third one, such that that triangle will make us have a ratio with both of them separately. And then we use multiplication to get the solution. Okay? What I'm trying to say is this. Make sure you pay attention carefully. Okay, we have done this when we're doing the proportion theorem. That's where the concept to do this question comes. You see, if you have the area, say, of x, okay, the area of x over the area of y, if they don't have the same height, those two triangles, they don't have the same height, they don't have the same angle, right? The only way is for you to identify a third triangle. And that third triangle must be provided in the question. Okay? It must be provided. But you have to see it. Okay? If you don't see it, you won't be able to do it. So that if I say the third triangle is maybe K, okay? Or let's use B, okay? Such that I can write X over B times B over Y. Okay?
Yes.
Oh. So that the good thing is that this ratio here, we will be able to find it because of the existence of a third triangle that we can find a ratio of this form. And then we can find that ratio is what? And then we multiply the two to get the solution. Okay, so it's a little bit complex. Right? So if you're not aware of the existence of a third triangle, you can get stuck forever. You will never be able to do it. Okay, you will never be able to do it. So that third triangle is what? From the diagram. Which triangle is such that it shares a common height with both triangles? It will be what? It will be what? It will be RBC.
Yes, sir.
Okay. RBC shares a common height with triangle ABC. it also shares a common height with triangle CRT. Okay, let me bring it back. How can I use it? Okay, let me use this one. The triangle that we are talking about is this. This is a common triangle for the two triangles. Okay, that triangle RBC. Okay, we can write the ratio of the area of ABC and triangle RBC. We can also write the ratio of the areas of triangle RBC and triangle CRT. Okay, with ABC, they share a common vertex here. So the height, you can draw it like that with ABC. Okay, with triangle CRT, they share a common vertex here. So the height, okay, we can draw a height from this point going down. Please don't assume that RT is perpendicular to BC. It's not. We have to prove that. Okay, but because they share a common vertex, the height can be drawn from there down to a point along BC. Okay, do you understand that? Okay, which part are you not understanding?
So how is the third triangle related to the other triangle?
Okay, so far I hope you are aware that number one, if triangles share a common vertex, it means that their height is the same. Therefore, the ratio of their areas will equal the ratio of their bases. Right? Also, if they share an angle, normally that's for similar triangles. If they have a common angle, we can use the area rule to determine the ratio of their areas. Okay? Now, for these two triangles, RCT and ABC, we can't find directly this ratio. So we have to identify a third triangle such that that third triangle shares a common height with RCT, it shares a common height with ABC. And then we use what I wrote here to determine that ratio. Where there is B here, that's the common what? Triangle. And this will be the ratio of the area of the third triangle and X. In this case, our X is the RCT. And our Y here is our ABC. And that's the area of the common triangle. Okay? All right, so let's carry on. So what I'm going to do, this is now 8.2.2. Okay? So I'm going to say the area of triangle RCT over the area of triangle ABC is going to be equal to, okay, is going to be equal to the area of RCT divided by the area of RBC. Okay, so this becomes area of RCT divided by the area of triangle RBC times the area of triangle RBC over the area of triangle, that will be triangle ABC. What's going to happen is we can find this ratio, and we will also find that ratio. It multiplies the two. Okay, we can't find this ratio directly. Okay, we can't directly. It's not possible because we don't have any dimensions in terms of the height, the bases, and so on.
So, what made you choose the triangle RBC as a third triangle?
I've already told you, I'm surprised, but let me repeat it. The reason is because RBC shares a common height with both triangle ABC and triangle RTC. Do you see it? Have you been going over your work?
Yes.
All right. I know you're writing a test, the financial maths test, but you have to work under pressure. Okay, from now on, you have to work under pressure. Okay? You have to work under pressure. If it means you have to sleep at 2 a.m. or 3 a.m., then it has to happen now. Okay. All right. Listen carefully. Listen carefully. We can't find the ratio of triangle ABC and triangle CRT directly. So we need to identify a third triangle such that that third triangle shares a common height with both triangles. And then we use our knowledge of mathematics, okay, which I showed you here. Okay? I showed you this. Okay? So, let's look at triangle ABC and triangle RBC. Do you see that they share a common vertex? Which means we can draw a perpendicular height.
Yes.
So we can write the ratio of the area of ABC and the area of RBC. So we can call that maybe that one. Okay? Then if you look at triangle RBC and triangle RTC, okay? Do you see that triangle CRT is more like it's inside RBC? And they share a common what? Vertex there. So I can draw a line which a perpendicular height from vertex R to a point along BC, which means the ratio of their areas will be equal to the ratio of their what? Bases. Do you get that, all of it? Sorry, Samkel, are you understanding it now? Yeah, the key concept is if two triangles share a common height, it means that if you are asked to write the ratio of their areas, it's going to be equivalent to the ratio of their bases because their height will be the same. Okay? So from here now, it shouldn't be a challenge to do the question. But what I'm going to do to make things a little bit easier. You see, for length RP, remember we got the ratio that's 5 is to what? We got it as 5 is to 2, remember? CP over what? Over PR. So I can call, since I've got Y here, I've got K, I can call this one 5x, and RP, I can call it what? 2x. I hope you understand that as well. Okay? Then, now I can go back and substitute here. Now I can substitute. I can substitute here. Okay? The area of RCT, let's go back to where it is. Okay? RCT. Okay? What's the base? The base is going to be TC. If we draw a perpendicular line from here to there, the base is going to be what? TC. And our TC will be equal to 2K plus what? Plus 5K, which is what? 7K. Okay? So it will be 7K. Okay? So I can write here, that area is going to be because we want the ratio of their areas is equal to the ratio of their bases. So we can have here 7K. Okay? And then the base, the length of the base of RBC is going to be equal from B to C, which is what? 8K. You see that?
Yes.
So it will be 8k. Right. Just as a hint, if you practice on, you get to this point here. The constant in the numerator and the denominator must be the same. If it becomes different, then you won't be able to get the answer. Okay? The constants must be the same. You can't have k on top, then you have y at the bottom or x at the bottom, or vice versa. If you get to that point, then you won't be able to get the solution. Times. Now, the area of RBC divided by the area of triangle ABC, they share a common height. And that common height is from here to the vertex there. Okay? So what will be the base for RBC? The base for RBC is going to be BR. You see that? It's going to be BR. So BR is equal to what? So we put Y here. Okay? So we put Y. Then the base of the area of ABC is going to be AB. And that AB is equal to Y plus 2Y, which is what? 3Y. So the constant cancel out. And you end up having 7 over 24. Okay. So this one was the last concept on proportion and ratio of areas. Right? Any question? Okay, so from now on, for that. Okay. For this question, what I would suggest, okay, is to write. Where can I write that? I think you need to write. Have another step somewhere, which is this. You can write area. You have to write this somewhere on your solution. Okay, the area of triangle. That's RBC. Okay, is equal to. Then you need to mention it's equal to. Okay, we have RCT RBC. So that will be equal to TC over what? Over BC. So we write this is equal to TC over what? BC. Then your reason here will be same height, same base. We can just write same height only. Okay, just write same height only. Right. For the other one, okay, you also do the same. So that will be area of triangle RBC all over area of triangle ABC is going to be equal to, that's going to be equal to, we put RBC on top, that will be BR over AB. Okay, so that will be BR over AB. And your reason, same height. Therefore, same base. Sorry, this is not supposed to be there. It's only same height. Okay. Okay. Only light because of the same height. That's all. Okay. They don't share. Their base is not the same. So we just write same height or common what? Common height. Okay. So you can start from there. Then you come to this equation. Then you substitute, and then you will be okay. Okay. Thank you, Mr. Mtembo, for reminding me about that.